So today we'll start the circular motion. Okay. So circular motion, as the name suggests, that in this particular situation the particles should move along a circular line. And whenever I am saying circular track, let us say this is the particle A, it is moving along a circular track. That means for that circle there must be one fixed point that is the center of the circle. About point O the particle moves. So whenever you study the kinematics, then we see that either the particle can perform a movement along the x-axis, or it can perform the movement along the y-axis, that the particle moves, okay, or it can move in a 2D path of the projectile motion. Okay. So in both the situation, all of the situations, the particle is moving either in a straight line or in a vertical line or along a 2D line in case of projectile motion. But now we go inside the another particular movement to study that it is a kind of motion which is known as the circular motion. So similarly, when you start the kinematics part, then we decide about the parameters. Then the velocity, acceleration, all those are the parameters displacement. Now, similar to those parameters, here also I should identify some of the parameters. Okay, associated with the circular motion. So circular motion may be of two types. Either the motion may be in a horizontal circle, so it is a horizontal circular motion, or it may be a vertical circular motion. Okay. So the circle drawn in a horizontal plane, like this is the circle. Let us say, give the example of a circular motion where the circle is like this. So this circle is a horizontal circle. Okay. So particle is performing a circular motion, that is horizontal circular motion. And for horizontal circular motion, can I see this is the axis of the circle? No. So there are different circles. One is a smaller one, another may be the larger one. So different circles may be there. But all the particles are performing circular motion about this common axis. And whenever I am saying axis, about this axis, the particles should rotate. Okay. In the other situation, when the particles are moving along the vertical circular motion, then what happens? The circle may be vertical. Now, whenever I am saying circular motion, now one thing must be clear to you. Let us say that this is the particle which is moving. So the green arrow suggests the direction of the velocity. Okay. Let us say the particle is over here at point A. Okay. So this is the direction of the velocity, tangent to the path is the velocity direction. Let us say once the particle comes to point B, the velocity is like this here. So between A to B, there is a change in velocity vector or not? Direction of the velocity vector is changed. Yes. That means the particle must have some kind of acceleration. Okay. Why? Because whenever I am saying the velocity is changing, either the velocity may change magnitude wise or it may change in a direction wise. In this particular situation, the particle velocity is changing in direction. Okay, that means there must be some kind of acceleration. There must be some kind of acceleration. Okay. So that acceleration is known as the centripetal acceleration, or in the other word, we can say that acceleration direction is always fixed. This yellow arrow defines the direction of the acceleration. Okay. How it comes in this direction, I will explain. But we first understand that there must be one acceleration for the circular motion. If the acceleration is not there, that means the velocity vector is not changing, that means the path is not circular. If I say particle performing circular motion, that means there must be one acceleration. Without acceleration, the particle cannot perform a circular motion. Like this is the universal system, where I am saying that there is a planet about which the particles are rotating. Okay. So that means for this particle, let us say this is the A particle, this is the B particle. So for A particle, can I say the radius of the A particle is this one? RA. And for the B particle, is the radius of the B particle. No. So both are different. And if I draw one particular line, then you can see that once the particle A is crossing that line, at the same point of time, B is not crossing it. No. That means they are not moving with the same speed. They are not moving with the same speed. The speed is varying. And also, since the speed is varying, that means there must be some kind of acceleration. So this is the example where I am saying these particles are performing a horizontal circular motion, and along that we should say how the velocity is changing or the vector is changing. Okay. Now, so we understand that for a system or the particle which may be treated as a point mass. Okay. Because every time I will consider this mass as a point mass, and if I say this is a point mass, should move along a circular path, then only that path is known as the circular motion. Now its distance is always constant with respect to fixed point. And that fixed point is nothing but the center of the circle, that is rho. Okay. Now the direction of motion is always changing. I have already said that. That means it is bound to be an accelerated motion. Initially the U vector is U1, finally the U vector is U2 vector. So the magnitude wise the vector may change. If the magnitude wise the vector is not changing, then also the vector should change why the direction is changing. And since the direction is changing, whether the mode is changing or not, that is immaterial. The velocity vector is going to be changed. That means it should be an accelerated motion. Okay. So there is an acceleration. Now parameters. Now we come inside the parameters. So if I draw a circle, now the nomenclature is like this way. Let us say the particle starts from this point. In the point A, from where the particle starts. The particle can rotate in this direction. There is the anti-clockwise direction. Okay. Or the particle can rotate in the other direction, that is the clockwise direction, in this direction. So if the particle is rotating in the anti-clockwise direction, then the angle measured from the positive x-axis or the positive, here the positive axis, because I am measuring the point from the y-axis itself. So then the angle is positive. Okay, this angle is positive. For the counterclockwise or the clockwise direction, the angle is negative. Okay, let us say at an instant you are seeing the particle is observing over here. So if I say this angle is 60 degree, you should write is minus 60 degree. Minus 60, yeah. Okay. Let us say at a particular instant of time you are saying this is the point of the particle. So now we measure this angle. Let us say it is 75 degree. Then like this way, if the particle is rotating on the clockwise or anti-clockwise, depending on that, the angle covered will be different. Okay. So this is the direction sense. Now, first we define the displacement. Now here in the kinematics, we define the displacement by the line joining between the initial and the final position. Now, direction is along the straight line, initial point and the final. Now here I should define the displacement as the angular displacement. Not only displacement, we should put one angular word to define the displacement. Now what is that number? That number is defined as theta. Now unit is radian. I have already said that if the particle starts from, so this is the O point, and this is the, let us say, the A point. So particle starts from point A. After some time, the particle goes to point B. So this is the distance that is well covered. So this is the length of the arc AB. Sir, in school we just today learned about radians. Oh. So here, what is the angle measured? That is the theta angle. Now what is theta? Theta is the angular displacement. Now since the theta is in the anti-clockwise direction, I know that this angle is positive. How to measure the theta? Theta is L by R or AB arc length divided by R. What is R? R is the radius of the circle. Okay, AB is the arc length. Now that theta has to be measured in radian. Now what is radian? Radian is nothing but the measurement of angle. Okay, radian is measurement of the angle. Let us say I draw a circle and I start to move along the perimeter of the circle, starting from, let us say, the point. Let us say this is the radius arc. If I move this distance, the arc length by another arc distance. Okay, so this arc length, let us say I am saying AB arc length is equals to R. Okay, then the angle subtended at the center of the circle is basically 1 radian. So this theta is equals to 1 radian, subscript is superscript is C. Okay, now let us say I am moving up to point C, where the AC length is another R, that means this length is another R. So what is the AC length? AC length is 2R then. Now, if I A to B is R, then B to C is another R, so AC is total 2R. So total 2R is R means now this angles AOC is making an angle 2 radian at the center. Okay, like this way, if I rotate this point and ultimately come back to this point, what I can say, if I move by distance of R, then the radian is 1 radian. If I move by distance of 2R, then the radian is 2 radian. If I move by 3R, then the radian is 3 radian. Like this way, if I move by 2 pi R, then the radian, okay, 2 pi. So 2 pi is basically the radian, that is nothing but equals to 360 degree. Okay, that is pi radian is equals to 150 degree. Okay, or you can say 1 radian equals to 180 by pi degree. Now what is pi? Pi is 22 by 7. 180 by 22 by 7. So if you divide this, gas number comes to around 57. Okay, So one radian, that is an approximate value. Okay. So you should take one radian. This is the correct conversion. One radian equals to 180 by pi degree. That is the correct conversion. You cannot write it is equals to degree. It is approximately equals to. Yeah. I should say it is the approximately equals to. So most of the situation you have to take this equation, or 1 degree should be equals to pi by 180 radian. Okay. These are the conversion from radian to degree or degree to radian. Okay. So this gives an estimate that radian is quite large now. Yeah, radian is quite large number because degree is 1 degree, 2 degree like this way. Now if I move up to say 57 degree, then only I can reach up to 1 radian. Understood? So radian is very large. So it will give only the estimate part, how large is radian. Okay. So if the particle is moving in the anti-clockwise direction, then means it is traveling positive displacement. And if the angle is moving in the anti-clockwise direction, then the displacement is negative. Understood? So now velocity. Now similar to the situation where we define the velocity for the kinematics, we define v equals to dx. No? What is x? X is the displacement. Similarly, here we define the angular displacement omega, that should be equals to d theta. Okay, d theta dt. Understood? What is theta? Theta is the angle. Yes. So theta is the angular displacement. If the particle starts from A, after some point of time the particle reaches at point B. So just now we see that theta can be written as equals to L by R number. Now what is L? L is the angular distance. So this is the distance. You know? So it is the distance by R. Can I say that?
Yes, sir.
So now if I differentiate it, so d theta dt gives what? R is constant and radius of circle is constant. So we are left with only dl dt. So that gives the changing distance. So changing distance means speed. So v by r, what is v? V is the speed. Okay. So that gives the basically omega. Understood? So omega where v is the speed, not the velocity. So theta equals to omega equals to v by r. Or so I got two expressions. So one expression is theta equals to L by r. And number two is omega equals to v by r. What L? L is basically distance. What is v? V is the speed. Okay. So these are the basically linear component. Linear component. Distance is basically linear component. Speed is basically linear component. So if I divide the linear component by the radius of the circle, then only I am getting the angular component. Understand? So one important observation from this expression, we can see that angular component should be equals to linear component divided by r. What is r? R is the radius of the circle. Okay. So omega is written as v by r. This is a scalar equation. Why scalar equation? Because v is a scalar quantity, r is also a scalar quantity. It is not a vector equation. Theta equals to L by r. This is also a scalar equation. Why? L is the distance, r is the radius. Okay. So though they are vector quantity, but I am using the expression, those are the scalar equations. So these are the scalar equations. Okay. So d theta dt is known as the instantaneous angular speed. Like you say, what is v? V is the instantaneous velocity. Okay. Similarly, SI unit is radian per second. Instead of meter, I am using a radian in what?
Radian.
Okay. Rotating, so it is over with an angular speed, that is radian per second omega. Okay. Now,
Sir, yesterday there was more test. Is it?
there is no time. I was out of station. So now, let us say there are three particles. They are rotating at different radius. Now, so if I say this radius is R1, then this radius is, let us say, R2, and the last radius is R3. Okay. So if I draw a vertical line, what you can see that all the particles are crossing this vertical line at the same time. Now, all the particles are crossing at the same instant. That means omega for each particle is same. So omega for R should be equals to omega for yellow equals to omega for green. Can I say that? All the particles will be same omega. But omega is what? V by R. Omega equals to V by R. So v by r is same thing. So that is velocity of particle rate given by rate particles are moving by r1. So should be equals to vy by r2 should be equals to vg by r3. Now, so that means the velocity is different. Can I say vr is equals to vy equals to vg? No, but omegas are same. Okay, omegas are same. Velocities are different. Now, another important observation is how much time is being taken. What is the time taken to complete the circle? That's called the time. So capital T is basically the time period. Time period. What is that number? That number tells you that how much time you take to complete one circle. So in order to complete one circle, what is the total distance you have to travel? 2 pi r.
Yes, sir.
2 pi r by t, that is the v number. Okay. So v is what? V is the speed. So greater the radius. Yeah, greater the radius, greater the distance, greater is the v number. Can I say that? Because
Yes, sir.
each particle they are taking same time, they are crossing at same instant means time for the three particles are same. So time for the three particles are same. That means what you can say, v will be greater for the particle having r number is greater. So r is greater for the green particle. So I can comment here that velocity of the green particle vg is maximum, then v yellow, then velocity of red particle. Understood?
Okay, sir.
The particles have same omega. Particles have same omega, but the velocity linear speed will be different. Why? Because the radius of the circles are different. Okay. So radius of the circles are different. So here also, let us say if I draw one particular line for our solar system, so I can observe that these lines are not cut by different planets at same interval of time. Can I say that? All the particles are crossing at different instant. That means time for the each particle is not same. Time for the each particles are not same. The radiuses are different. So that means the time, what is the time? That is 2 pi r by v number. Okay, 2 pi r by v. So that t is not constant for each particle. For r, it should take 365 days. So for
Yes,
r,
sir.
capital T is 365 days. So for r, if I put the r number and v number, then it will be giving the value of capital T. Similarly, for other planets, if I put the r number and v number, we get the different t. Why? Because the time will be different, because all the planets are not crossing at the same instant of time.
Okay.
So they are crossing at different instant of time, so time will be different. Time will be different. Okay.
Okay.
Now comes to the concept of angular acceleration. Right? Because we have already discussed about the two different parameters. One is the theta, another omega. Now come to the another concept of angular acceleration. Now what is the notation for that? Okay. So
Okay, sir.
the angular acceleration. What is alpha? Similar to the situation of the linear acceleration. If I say A is the linear acceleration, so A is rate of change of velocity. Yeah, rate of change of velocity.
Yes, sir.
Similarly, here also I can write alpha equals to d omega dt. Am I right?
Yes, sir.
D omega dt. Okay. Now what is omega? Omega is again v by r. Omega equals to d v by r dt. Can I write it? Again r is
Yes, sir.
constant. Again r is constant to 1 by r dv dt. Now what is dv dt? dv is a linear acceleration. A by r. Okay. So again, the same equation, that the angular component is the linear by. Okay. So every time you are getting the angular component of the acceleration is known as the alpha. That's the linear component by. Okay. And here this linear component is known as the tangential acceleration. This linear component is known as the tangential acceleration. Okay. Why? Because there will be two different accelerations. Since the particle is rotating, so one acceleration is directed towards the center. Another acceleration is tangential to this. This number is known as the AT number. This number is the radial number AR. Okay. So since the particle is rotating, so whenever the particle is rotating, that means there must be one acceleration. Without that acceleration, the particle cannot change the direction. So since the direction is being changed, so acceleration must be. And that acceleration is always towards the center of the circle. And AT is what? AT is the tangential acceleration. If the AT is there, then only the alpha will come in. Why? Because if I say A number or rather if you say 80 number is 0. So what happens to alpha? Alpha number becomes 0. Okay. Alpha number becomes 0. So whenever the alpha is non-zero, that means if the angular acceleration is there, then the particle has to perform a non-uniform circular motion.
Sir, then what is the problem?
A non-uniform circular motion. Why? Because at every time, because of presence of the AT, let us say here the velocity is V1. Now here the particle velocity will be V2. And if the AT is positive, V2 must be greater than V1. Here the particle should move into V3. So V3 should be greater than V2. Like this way, the velocity will increase. Now since the velocity is increased, then it should be known to be a non-uniform circular motion. Understood?
Okay.
Angular acceleration is there, then the particle must move with normal non-uniform circular motion. Okay. So alpha is basically d omega dt. That can be also written as d2 theta dt square. SI unit is radian per second square. Okay. SI unit is radian per second square. Now, consider one situation where the particle is a particle and moving with some alpha is given, some omega is given. Okay. And along with that, it will start from point A. After some point of time, it goes to point B. And clearly you can see here that if you see V1, here the particle velocity is V2. V2 is more than V1. Arrow is longer. Nah, why? Because the particle is moving some kind of motion. So V2 is more than V1. That means it is a non-uniform type of motion. Understood? Now, in this particular situation, these are the three vector coordinates. What are those? Alpha, theta, omega, and alpha. These three are vector coordinates. But these three are known as the axial vectors. Why? Because they have axial vectors. Axial vectors. These are called axial vectors. Why? Because the direction of these vectors are fixed. So earlier one, what happens? Let us say in a linear path, the particle is traveling in this direction. So U is taken to be positive, and acceleration in the opposite direction A is negative. Okay. So in some situation, the particle may move in a positive direction, and acceleration is also positive. So it may be either positive, it may be either negative. All possibilities are there. All possibilities are there. But here, the possibility of rotation is either clockwise or anti-clockwise. Nothing more than that. No. So that means the direction are fixed. What are those directions? If the particle is rotating in anti-clockwise direction, where the anti-clockwise rotation is there. Here the particles are rotating in anti-clockwise direction. So for that situation, you have to fold your right hand in anti-clockwise direction. Now, once you fold your right hand in anti-clockwise direction, the thumb will be pointed outward. Now, if I say there is a plane and along that plane the particle is rotating in this direction, anti-clockwise direction. So if I rotate my finger in the anti-clockwise direction, so right hand thumb will be pointed upward, isn't it?
Yes, sir.
Okay. And if the same particles are rotating in the opposite direction, in this direction, if I rotate my thumb, I rotate my fingers along that direction, so these are the only two possible. Okay. So if these vectors are upward facing, so then these are known as the out of the plane. Out of plane. And for out of plane, we should use the symbol dot and circle. If the arrow is facing downward, then we will know the into the plane. Into the plane. And for into the plane situation, we have to use a cross and then encircle. Okay. So these vectors are axial vectors. Either it will be upward or it will be downward. Okay. It cannot change the direction. It cannot change the direction. So depending on the direction of rotation, I can sense in which direction my thumb is going. And accordingly, you have to adjust the direction. Okay. So direction of angular vectors are given by the right hand. So this is the right hand thumb. Okay. So in this situation, the particles are rotating in the anti-clockwise direction. No? Anti-clockwise direction. So once I fold my hand in anti-clockwise direction, thumb is pointed outward. So outward means dot, encircling out. Okay. And there is another possibility that it will be inward. So in this situation, let us say the particle is moving in anti-clockwise direction. So once the particle is moving anti-clockwise direction, can I say that theta is upward?
Yes, sir.
Omega is also upward, alpha is upward.
Yes, sir.
There. If alpha is not there, then forget about it. But whatever the situation, theta and omega is there, and theta is omega there, that means it is upward. If the same party is rotating in the opposite direction, then these vectors will be in the downward direction. Okay. So that's why these vectors are known as axial vectors. What is this axis? This axis is the rotational axis. So all the particles are rotating about the z axis. No? So this axis about which the particles are rotating. That means the direction of the theta omega alpha should be either along the z axis or negative z axis. That's why it is known as axial vectors. Understood?
Okay.
So now we go into the equations. So since the particles are moving along a circular path, and if I say the alpha number is constant, alpha number is constant. Alpha number is constant. I derive this equation for constant value of alpha. So alpha is what? Alpha is basically d omega dt. D omega, rate of change of angular velocity or angular speed.
Okay, sir.
So if I write d omega, that should be equal to alpha times dt. Now integrate it. So omega limit is when the time is 0, let us say omega is initial omega is omega naught, final omega is omega, so time is t. So here the alpha is constant taken out, integration dt means t, so t. So here it should be omega minus omega naught. So finally if I rearrange it, so omega should be equal to omega naught plus alpha. First equation. Got it?
Okay.
Now second equation. Now once I write the omega number, now omega can also be written as omega is nothing but equals to d theta dt. Yeah, and that is equals to omega naught plus alpha t. Now d theta is what? D theta is equals to omega naught dt plus alpha t times dt. Now again integrate it. So at t equals to 0, 2t. T equals to 0, 2t. At t equals to 0, let us say theta is 0. At t equals to 3, let us theta. So left hand side theta, that's equals to omega naught t plus half alpha into t square. This second equation I am getting. Okay.
Okay. Sir, in this we are basically deriving the equation of the motion.
That's the heading. Equation of circular motion. Now last one equation is nothing but that. If I want to say that omega is known, theta is known, okay, and alpha is also constant. So can I write alpha equals to omega into d omega ds? So similarly, it can be written as omega d omega d theta. Okay, alpha. Why? A equals to v dv dx. Same logic, omega d omega d theta.
Okay.
Okay. Alpha can also be written as omega d omega d theta. Now take that equation. Let us say this is alpha. So omega into d omega should be equals to alpha into d theta. Now integrate it. When theta equals to, let us say omega naught. When theta equals to theta, let us say it is omega. So left hand side becomes omega square by 2 using omega naught to omega equals to alpha into theta. That is finally omega square equals to omega naught square plus 2 alpha into theta. These are the three sets of equation, and these equations are analogous to our equation in kinematics. So in kinematics, what you write? V equals to U plus A. First equation. Second equation is S equals to UT plus half AT square. Third equation is V square equals to U square plus 2S. Can you see the similarity between these three equations? This is the equation
Yes,
number 1. This is the equation number 1. This is the equation number 2. This is the equation number 3. This is the equation number 3. This is the equation number 4. All three are similar to each other. Okay. So only thing is that you have to replace the variable property. Once I replace the variable, then only I can get the answers. And these are the different situations. What is omega naught? Omega naught is the initial angular speed. And these three equations are applicable only when the alpha number is constant. Similar to the situation what we say that these three equations are applicable only when a number is constant. X is constant. Okay. So these three equations are known as the equation for the circular motion. Okay. It is written. So with constant angular acceleration alpha, then only I can replace these. So equation number 1, 2, and 3. Okay. So those are the analogous equations corresponding to our kinematics. When the equations are different, meaning when the alpha number is not constant, then you have to go for the differential equations. So for that, you should write d equals to ds dt. So corresponding to that, we can write omega equals to d theta dt. Acceleration equals to dv dt. That means the acceleration alpha. Yeah, we should write alpha. Why? Angular acceleration equals to d omega dt. And third one is alpha equals to also written as a v dv ds as the acceleration is to omega dt. Okay. So these sets of equations are to be used only when your acceleration is not constant. It is variable. Whenever alpha is variable, then only we should go for these equations. Okay. Logic remains same. Logic remains same. Let us do with one calculation. Let us say the theta number is given. You are asked to calculate the omega average and omega. If simply omega is written, then this omega is instantaneous. Instantaneous angular speed. Okay. Now what is omega average? So omega average is the average angular velocity. The average angular velocity is theta final minus theta initial by delta t. Total angular displacement. Similar to the average speed. So total distance by total time or average velocity, total displacement by total time. Same logic goes for the omega average, total displacement by total time. What is total displacement? Final minus initial. What is final? Final is 2t square plus 2 when t equals to 2 seconds minus 2t square plus 2 when t equals to 0 seconds. Starting is 0. Divided by delta t is 2. So answer is, if you put 2, so 4 to the 8 plus 2 means 10 minus 2 by 2. That means 8 by 2 means 4 radian per second. Understood? So this is the omega average. Now, omega instantaneous or omega instantaneous differentiate. So theta is given as 2t square plus 2. So d theta dt will be the value of omega. Very instantaneous. So it equals to 4t. So 40 equals to 2 seconds, which will be 8 radian per second. Okay, 8 radian per second. So whenever you are asked to calculate simply omega, that means it is an instantaneous curve. And if you are asked to calculate the average, it should be clearly mentioned in the question. Okay, I am writing omega and you are indirectly asked to calculate the omega average, it is not that. Okay, if I want to calculate the average quantity, then I have to mention it clearly. If nothing is mentioned, every time you assume that number is the instantaneous. Okay. That number is the instantaneous. Now, another type of example that omega is given as 2t, you are asked to calculate theta. What is omega? Omega is basically d theta dt. D theta dt equals to 2t. So what you can write, d theta equals to 2t dt. Now integrate it. At t equals to 0, let us say theta equals to 0. Nothing is static. Okay, at t, let us say theta is theta. The left hand side becomes theta, that should equals to t square by 2 between 0 to t. That is t square. Okay. So theta is equals to how much? T square. That is the answer. Okay. So from one format I can change to other format also. I have given the value of omega. I want to calculate the value of theta. I can do that. Okay. Theta value is given, I want to calculate the theta number. That theta can be calculated from the equals. Okay. Now, from here on, now we divide the entire part into two different categories.
Sir, can you use
So now the part has been chapter has been divided into two parts. One is called the uniform circular motion, another non-uniform circular motion. Okay. So uniform circular motion means the speed of the particle is constant. So let us say the particle is rotating about a circle, and at this point it starts the rotation, and let us say it is moving with a 2 meter per second speed. Okay. After some point of time, when the particle comes at point B, it is again moving with 2 meter per second. Okay. That means the speed is constant, it is not changing. At C, direction is changing. At C point, the velocity is again 2 meter per second. So every time the speed is not changing, so speed of the particle is constant, that means mode of the V vector is constant. Okay. I cannot say V vector is not constant. V vector is not constant. But
that is the magnitude very constant.
and if magnitude is constant, then what you can say, omega that is equals to V vector mod divided by R, that number is also constant. Nah.
Yes, sir.
I mean, omega equals to constant. And if omega equals to constant, so d omega dt is what? D omega dt, that is alpha, that is equals to 0. Why? Because it is constant. So
Yes.
alpha equals to 0. So that means the particle is performing uniform circular motion. So what is the essence of that? So for uniform circular motion, omega number has to be constant. Now come to the second situation. If I say the same particle is rotating, but now starting from point A, let's say the velocity is 2 meter per second. After some point of time, the velocity becomes, let us say, 4 meter per second. After some point of time, the velocity becomes, let us say, 8 meter per second. That means it is continuously changing its speed.
Yes, sir.
So at different location, the speed is different. So speed of the particle is not constant. Now in that situation, speed of the particle is not constant, means mathematically what you can write, mod of V vector is not constant.
Yes, sir.
It is changing. And if mod of V vector is changing, that is omega, that is mod of V vector divided by R, that is also changing. No, it is also
Yes.
constant. So omega is not constant. And since omega is not constant, alpha is not equal to 0. Why? Well, alpha equals to d omega dt, and that means alpha is not equal to 0. So then that particular motion is known as the non-uniform circular motion, AUCM. First one is the UCM, second one is the MUCM. Okay, so these are the two different category of motion. Now for UCM, it is a periodic type of motion. Not only UCM, NUCM is also periodic type of motion. Why periodic type? Periodic type because if I start from point A, after some point of time, the particle will come back to bottom.
Yes, sir.
If the particle is repeating its path, then it is known the periodic motion. Now, what is the time period? So time period is circumference of the circle divided by speed. What is the circumference? That is 2 pi
Okay.
by v. That is the time period of rotation. Okay. So how much time it will take? It will take 2 pi r by v for every rotation. And if it is a uniform circular motion, if I say for the first rotation, let us say this number is millisecond. Okay. So for the second rotation, it will take the same time. Third, same time. Why? Because the speed is not going to be changed. Okay. Speed is not going to be changed. But that number is different for non-uniform. So for the non-uniform situation, let us say if alpha is positive, so V will always increase. Nah. So V is always increase means time will decrease then. Let us say for the first rotation, it will take 10 seconds.
After the speed is increased, the time is supposed to be 9 seconds.
Let us say 8 seconds, then
8
seconds, 6 seconds, like this, it will go on reducing. Okay, you go on reducing. If the particle is performing non-uniform motion. Okay. Relation between linear and angular.
Sir, if it goes reducing like that, then at the point it will be 0, right?
No. It cannot be a zero.
Then
Very close to
then
zero.
what is the limit for that?
Very close to zero, but not equal to zero.
Okay.
Tending to zero. Why? If you go on increasing, so what happens to the V number? V number will be tending to infinity. I cannot say it is infinite. It goes to infinity, not all. So V is tending to infinity, the T tending to zero, not equals to zero. T tending to zero and T equals to zero, both are different. T can never be zero. T can never be zero, but is very close to zero. That's why it's called tends to zero. Okay. Not actually zero, but what you can say that it is very close to zero. Okay. Now, relation between the linear and the angular quantity. So, we have already said that the linear quantity in this situation is basically the v value. Okay. So, if I say the particle is moving with v speed, and here also the speed is v, that means the particle is moving with constant omega. Omega is constant. Okay. And what we define that theta equals to L by R and d theta dt, that should be given by value as 1 by R into dl dt, and the dl dt number is basically v. So the v by R is equals to omega. So this is the equation that connects the linear and the angular quantity. Okay. Now what is v vector? V vector is written as omega cross r. Okay. V vector is basically the omega vector cross r vector. So omega vector cross r vector. So omega is the first vector and r is the second vector. R is the radial vector. Omega is what? Omega is the thumb tool. About the according to the thumb rule, you have to define the omega direction and then cross it. Okay, so that is the value of v vector, v direction. Let us say in this situation. So we know that v vector equals to omega vector cross r vector. This is the expression. Now in this situation, let us say at this instant you are saying that particle is moving in this direction. So this is the direction of v vector. Now what is the omega in this region? Omega is in this direction. What is r? R is in this direction. No. Omega is upward. R is towards y. Okay. R is towards y. Understood?
Okay.
So according to the cross product rule, can I say omega cross r is along the v direction, v vector direction?
Sir, according to rule,
Cross product.
cross product. Okay.
Omega vector cross r vector is directed along the v vector.
Yes, sir.
Nah. So that means it will satisfy this equation. Okay. Now come to the situation of linear and angular acceleration. Linear and angular acceleration. Now, regarding the acceleration, what you should write that, let us say the particle starts from point A and goes to point B. And goes to point B. So, because of this movement, what is happening? It is having an acceleration. Why? Because now I am saying the particle is changing its speed. Now the particle is changing its speed. Got it? Now the particle is changing its speed. So, if the speed is changed, then the acceleration has to be there. Then the acceleration has to be there. Without the acceleration, particle cannot change the speed. So that means that acceleration is the tangential acceleration. Okay. So here there are two components of acceleration. One is called the radial acceleration AR, as well as the tangential acceleration AT. Okay. Now why AT will come? Because the if I say the speed of the particle is changing, that means now the AT will come. And AR is always there. Why? Because the particle is changing its direction. So since the direction is being changed, so AR is always there. I cannot change that. Okay. Is always there. Now I want to check what is the relation between the AR AT and what is the expression for AR. Okay, I want to check that. Now for that, what you should do that A vector can be written as the component of two acceleration. Okay, what is that? So let the particle is at point A. At this point, particle has the one acceleration directed towards the center, that is the AR. And at that point, another acceleration is along AT. Okay.
Okay.
So these two vectors will give the value of A net vector. What is that? So A vector is written as a minus omega square r into r cap. What is r cap? R cap is the unit vector along this radial direction, r cap. Okay. And there is another theta cap. Theta cap is what? Along the tangential direction theta. This is a theta cap. So I introduced different unit vector. One is r cap and another is theta. Along r cap, opposite to r cap direction, the acceleration is there. That acceleration is called the radial acceleration.
Okay.
Along the theta cap, the acceleration is there. That's called the tangential acceleration. Okay. This is the idea. Idea is like this. Let us say I draw a radial vector along this direction. Okay. Radial vector along this. So along this direction, I identify that this unit vector as r cap. Okay. And tangent to that, I identify another unit vector, that is the theta cap vector. Okay. So these are two unit vectors. Ideally, initially the unit vectors was I and j. What is I? This is the x-axis I vector, and this is the y-axis j vector.
J.
Okay. Now I replace the I and j by another two vectors, unit vector. One is along the radial direction, and another is the tangential to that. That will define the theta direction. And we say that the acceleration has two components. One is along radial and another is along tangential. Okay. Now what is AR quantity? AR is given as the omega square r, and direction is negative. That means always toward the center. And AT is what? AT is basically r into I. The tangential acceleration. Okay. So the two components of acceleration, and these two components, what is the angle between them? They are 90 degrees with each other. They are 90 degrees with each other. So that means resultant acceleration is what? Root of that. So total acceleration is equals to AT square plus AR square. Can I say that?
Yes.
Square plus AR square. So that is the net acceleration. Okay. So if the particle is performing a circular motion which is non-uniform, then only the alpha will be there. So this number is equals to 0 for UCM. Understood? Why?
Yes, sir.
UCM as alpha equals to 0. Okay. So
Yes,
for
sir.
UCM, ANAT is what? ANAT is only AR. Only AR radial component is there. But for non-UCM, the angle is not. So the acceleration.
Okay.
Okay. So
Sir, and the question they are here is using
you have to understand. You have to understand from the question itself. So for UCM, omega is constant, that is V equals to constant, that is AT equals to 0. Okay. So only equation of acceleration is omega square. Okay. So what is the important point regarding that? So mod of dv vector dt. What is that? That is rate of change of velocity, which is the acceleration, and mod of that is nothing but the a net. Okay, that is not equals to 0. Why? Because net acceleration is omega square. Okay. Now d of mod of v vector dt. What is mod of v vector? Speed. So speed. Rate of change of speed is equals to 0. That is true. Why? Because if the part is performing UCM, so speed is not going to be changed. If the speed is not going to be changed, the rate of change of speed is 0. And third one is a vector is not constant. Why? Because mod of a vector is constant. A vector is not constant. Why? Here the acceleration is this one, omega square at this position. Here the acceleration is omega square by r in this direction. So every time the acceleration is towards the center. So acceleration is changing its direction. That is vector wise it is not constant. Why? Mod is constant. Understood? Mod of acceleration is constant, not the vector is constant. It is not a constant vector. It is not a constant vector. Now similarly for non-uniform circular motion, omega is not constant, v is not constant, at is not equal to 0. So for this situation, both the accelerations will be there, here and at. And if both the accelerations are there, then net acceleration should be square root of ar plus it. Okay. dt of vector mod gives the rate of change of speed, that will be always 80 tangential action. That is r alpha. Okay. Now direction of net force should be along direction A net. Why? Because if I apply the Newton's law, so F equals to what? F net equals to, I can write A into A net. Now here the net acceleration is resultant of AR and AT both. And if the resultant of AR and AT is there, that means net acceleration will be somewhat of different angle, and for that the force will be also different. Understood? So precisely there will be two different type of problem. One is for the uniform and one is for the non-uniform situation. Okay. And you have to be very careful regarding the decision making, whether you are doing the uniform motion or the non-uniform motion. So that can be understood if the alpha is given or not. Okay. If in the question the value of alpha is given, then it is a non-uniform. So alpha is given. So N you say clearly say. Okay. Why
Okay.
alpha is there? Now alpha is given.
Okay.
Omega initial is 0, R is 1. Has to calculate the net acceleration after 2 seconds. So now net has two parts. One is 80. 80 is basically R into R. So what is that? R is 1, alpha is 2 t square. So after t equals to 2 seconds, it should be equals to 8 meter per second. Unit for AR and AT is meter per second.
Okay.
Okay. Now regarding the AR, what is AR? AR equals to omega square into R, but omega is not given. Okay, for that the expression for the alpha is given. So if alpha equals to 2t square, that can be written as d omega dt. Now alpha equals to 2t square means it is d omega dt. So d omega equals to 2t square into dt. Now integrate it. Initial omega is given as 0, so time is 0. At t equals to 2 seconds, let us say omega is omega. So here omega should be equals to 2 times t cubed by 3. So 2 t equals to 2, so 8 into 2 is 16 by 3 radian per second. Okay, so that will be the omega number. Corresponding with that omega, what is the AR number? Now I can calculate the AR as omega square into R. So 16 by 3 whole square into R is 1. So that is the AR number in meter per second square. Meter per second square. Acceleration. Okay. Now you are asked to calculate the net. A net should be how much? A net should be under root of 80 square plus AR square. What is 80? 80 is 64. Plus AR square means 16 by 3 whole to the power 4. Okay. So root of that will be the answer in meter per second. That will be your answer. Okay. So whenever the value of alpha is given, that means you are supposed to solve the non-uniform motion. And whenever non-uniform is there, so there must be two acceleration. One is called the tangential acceleration and another radial acceleration. And you are asked to calculate the net. So net should be square root of 80 square plus AR square because these are the normal components. Okay. So at any instant of time, what you are saying, you are seeing that the particle has AR in this direction and AT is in this direction.
Okay, sir.
The resultant of these two is the net acceleration in this direction. So net will be in this direction. Okay, you can calculate this. So you calculate this for the answer. Okay. So now the second concept regarding the circular motion is that whenever I am saying the particle is performing a circular motion, so that means I have to go for a calculation of radius of curvature. Okay. Now what is that? If the path is bended, so let us say this is the path along which the particle is traveling. Okay. So let us say start from this point. So along this path the particle will move. So at any point, let us say at point P, you want to draw a circle. Okay. So once
Sir,
you
point B.
at point P, you are willing to draw a circle, so
Okay,
that
sir.
it will touch the point P. So at point P, it should tangent. Okay. Similarly, at point Q, you want to draw a circle such that at point Q, it will touch the tangent. It will circle like this. Yes, only one single point of contact will be, and that point is nothing but the tangent to the circle. If you draw that particular circle, then that radius of the circle will give the value of radius of curvature known as r. Got it?
Okay.
You can see this animation where the different circles are being drawn, and in some situations the circle is of very small size, in some situations circle will be very large. Okay. Now what the concept of radius of curvature? Radius of curvature means higher the value of radius of curvature means flat surface. If I say there is a particle moving along a straight path, okay, for that if I want to draw a tangent, so whenever I am drawing the tangent, I am ensuring that there are 2 points very close to each other. Let us say this is the one point P, P1, another point is P2. Tangent is touching the P1, P2 both. Okay. So here also if I say this is one point P1, here point P2, can I draw a circle which is touching the P1, P2 both? Yes, I can draw it, but for that circle, the radius of curvature should be infinitely large. No?
So radius of curvature should be
Infinitely large.
okay.
So if the surface is flat one, R will be less. Radius of curvature will be less. If the surface is curved one, then the radius of curvature will be more. So meaning is that smaller the radius of curvature, so RC is more means more folding or more bending. No, more bending. If RC is on the higher side, so more flat. So surface is more flat. For a particularly flat surface, RC number tending to infinity. Okay. RC number tending to. Now mathematically I can calculate the RC with this equation. d2y dx square divided by 1 plus dy dx whole to the power 3. Okay. Absolutely. Why? Because this is mathematical. Why? Because if you want to calculate the radius of curvature with this equation, then you should know the value of y. Once you become y, then only you can differentiate. That means the function should be known. If the function is known function, then only you can apply this.
Okay.
That means it is purely under the mathematics. In mathematics, you have to study this equation and you have to apply this equation provided the function is given to be. But here no function will be given. So you have to estimate y from the judgment. Now what is that judgment? So for that what you should do, if you say this is the circle, so that means at this point P, the particle is performing a circular motion of radius RC. Can I say that? Particle is circular motion of radius RC. At that instant. So at that instant, if the particle is performing circular motion, so you know that at that point, let us say the particle moving with velocity v. Okay. So for this, what you know that along this direction, radial acceleration is either omega square into r or can be written v square by r. Why? Because omega is equals to v by r whole square into r, then v square by r. Understood? So radial acceleration two components, two expression. One is omega square r, another is v square r. So for calculation of the radius of curvature, I should go for the v square by r. So that will give the value of. So once you know that AR, that's equals to V square by R. So that R is our RC. Now, that R is our RC. So RC is what? RC equals to V square by 2. What is V? V is the perpendicular component of velocity. What is AR? AR is the acceleration perpendicular to V. Now, in this situation, in this circle, what you understand that in this situation, A is R should be in this direction and V is perpendicular to the. So angle between AR and V should be how much? 90 degree. So component of acceleration is perpendicular to V, that is acting as a AR.
Okay.
So clearly the AR number should be perpendicular to V. Then only you can use that AR. Otherwise, take the component which is perpendicular to V. Okay. So let us do this.
Okay.
Let us say the projectile is there, it is thrown from a point A, and you are asked to calculate the radius of curvature once the particle reaches at the topmost point. That is at this point. Okay. So once the particle reaching at that particular point, only the velocity, that is ux, is remaining, no uy component. And what is ux? 10 cos 53. Can I say that? That means it is 6. So at the topmost point, the particle has only velocity along the x direction. No y component of velocity is there. And at that point of time, what is the acceleration? Acceleration is g acting downward. So this is 90 degree. That means g is nothing but our AR number. Okay. So if I do a circle at this situation, the circle will be like this. So what is the radius of curvature? Radius of curvature is V square by AR. So V is 36 divided by 10 is 3.6 meters is your answer. Okay. So why? Because at this situation, the U and G, or the acceleration, are perpendicular to each other. If these are perpendicular, then only you can directly apply the formula. You don't have to take any component. You don't have to take any component. You can directly apply it, and you are getting the answer.
Okay.
Got it?
Okay.
Now, come to the second type. When you are asked to calculate the radius of curvature after polarization. Now, for that, you have to do the entire thing. Is that, let us say at this point of time the particle is projected. So what is ux number? Ux equals to 50 cos 50. 50 cos 50 means 30. And here it should be 50 sin 53 means 40. Uy is 40.
Yes, sir.
Okay. If Uy is 40, what is the total time of flight? T should be equal to 2 times of Uy by G. That means 2 times of 40 by 10 means 8 seconds. Can I say that? 8 seconds.
Yes, sir.
So you throw the particle at point A and comes to ground at 8 seconds. So it will be at C point, midpoint, when the time is 4 seconds.
Yes, sir.
That means 1 second means the particle should somewhere over here P. Okay. So at point P, what is the velocity? At point P, velocity x component remains same 30. What happens to the y component? Uy should be written as Uy minus gt. Now,
Yes, sir.
Uy is 40, g is 10, t is 1 means 30. That means at point P, if you clearly see that at point P, there are two components. Velocity, one is 30 horizontal, 30 vertical. Now, that means at this point, resultant velocity is what? Resultant velocity is 30 root 2 in this direction. Now, 30 root 2. This angle is 45 degree. Can I say that? That is our V number.
Yes, sir.
That is our V number. Now, at that point, acceleration is still vertically downward with G. But this G is not perpendicular to this. So for that, you have to take
Yes,
a
sir.
component of acceleration which is perpendicular to V. That means you have to take this component. What is this angle? This angle is again 45 degree. Now, so this component G cos 45 means G by root 2. That is nothing but our AR. Why? Because now this number is perpendicular to V number. Understood? So radius of curvature at point P should be equal to V square by AR. What is V square? 30 root 2 whole square. Divided by AR. AR means G by root means 10 by root 2. Simplify it and you got the
1,800 we can.
what are the answer? Okay. That is the value of RP at that point.
Okay.
Understood? So whenever you are willing to calculate the radius of curvature, you have to take care about that particular formula, that is V square by AR. RC should be equals to V square by AR. And mind you that AR should be perpendicular to vehicle.
Okay.
Acceleration should be always be perpendicular to the vehicle. You can calculate. Otherwise, you can
Okay.